Every developer fears this exact moment. You pull the latest changes, and instead of a clean merge, Git throws this absolute mess at you. We're talking conflict markers, angle brackets, equal signs, and absolutely zero explanation of what just happened. Well, welcome to this explainer. Today we're going to completely demystify this process. We're going to understand exactly why merge conflicts happen, how Git actually detects them, and why they're honestly not nearly as scary as they look. So let's just jump right in.
Right, so when an auto merge fails, Git injects what looks like a terrifying wall of garbage text directly into your code editor. You get these less than signs pointing to head, some random equal signs in the middle, and then greater than signs pointing to your branch name. And look, if you've never been taught what these actually mean, it literally looks like your file is completely corrupted. But what if I told you this isn't Git breaking your code? It's actually Git leaving you a very organized, highly specific note. To understand what this note is trying to tell us, we first need to take a step back and look at how Git actually views your project's history.
Okay, let's shrink ourselves down for a second and take a journey inside Git's internal logic. Think about a timeline of your code. A week ago, we had our initial commit. Then, a few days ago, the path split. One developer kept working away on the main branch, reaching the main branch tip today. Meanwhile, you branched off to build an awesome new feature, reaching your feature branch tip today. Git is tracking these as two completely independent timelines. When you finally ask Git to merge them back together, it doesn't just smash the two newest files together and cross its fingers. No way. It uses a very specific historical reference point to figure out what to do.
And that brings us to the absolutely crucial concept of the common ancestor. Think of this as a glowing node right in the middle of our timeline. This is the absolute foundation of how merges work. When you initiate a merge, Git actually traces backward from the tips of both your current branch and the incoming branch to find this exact shared node. The common ancestor is the last point in time where both branches completely, 100% agreed on the state of the code. Git takes a look at this historical file, then it looks at your new file, and finally it looks at their new file.
So let's put a formal technical name to what's happening under the hood here. It's called the three-way merge. It's an algorithm where Git compares the latest commits of your two branches against that shared common ancestor we just talked about. Picture it like this. Git essentially sets up three panels side by side. It scans down the common ancestor line by line, and then checks your branch and their branch to see exactly what changed since that shared starting point. 1, 2, 3. That's your three-way merge.
Now, most of the time, this three-way merge is completely invisible to you because it just works perfectly. Imagine the common ancestor has a 100-line file. On your branch, let's call it feature A, you modify line 10. On their branch, feature B, they modify line 50. As Git's algorithm methodically scans through, it sees that your edit and their edit are in completely different, non-overlapping parts of the file. Git basically says, awesome, I'll take your line 10 and their line 50, and it seamlessly combines them into one resolved file. This is an auto merge. It happens in a fraction of a second, and you never even see it.
But what happens when that automated scanning hits a brick wall? Let's look at how a collision state builds. Imagine in the main branch, a teammate updated a configuration file, changing the project version to 1.5. But on your feature branch, you updated that exact same configuration file, changing the version to 2.0. Both of you modified the precise same line of code that existed in the common ancestor. When Git scans down and hits this specific line, it sees an edit on the left and a completely different edit on the right. Bam! You have a collision.
And this scenario brilliantly illustrates the core truth of merge conflicts, which is summed up perfectly in this quote from our sources. Git doesn't know which code to keep and which to discard. You see, you have to think of Git as an incredibly cautious, hyper-literal assistant. It absolutely refuses to guess what you meant. Should the project version be 1.5 or should it be 2.0? Git has zero context for your business logic. So, rather than recklessly overwriting your teammates' work or just throwing away yours, Git hits the pause button, stops the entire merge, and politely asks for a human to step in and make the final call.
Section 1. Decoding the conflict markers.
All right, so now that we know exactly why Git pauses the merge, let's translate that intimidating wall of text we saw earlier. Here is the anatomy of a conflict marker, progressively broken down. Step 1. It starts with those less than signs pointing to head. Head simply represents the current state of the branch you are actively on right now. Everything below this line is your code. Step 2, the equal signs. This is literally just the divider. It separates option A from option B. And step 3, everything below those equal signs is the incoming code, the branch you are actively trying to merge in. capped off by the greater than signs and the branch name. And honestly, that's it. It's just Git saying, hey, here's what you have and here's what they have. Please pick what you want.
Section 2. Resolving the conflict.
Now that we can actually read the multiple choice question Git is asking us, how do we answer it? Well, here are 3 standard resolution methods. First up, the manual edit. If you're using a terminal editor like Nano or Vim, you literally just use your backspace key to delete the markers, get rid of the less than signs, the equal signs, the greater than signs, and you manually type or format the code exactly how you want it to look. Method 2 is using an IDE GUI like VS Code. VS Code is great because it highlights these sections in bright colors and gives you these really handy buttons sitting right above the conflict that say accept current, accept incoming, or accept both. You just click a button and it does the cleanup for you. And finally, method 3, CLI flags. If you know for a fact you strictly want your branch's version, you can just run git checkout-hours. If you strictly want the incoming branch, you use -theirs. Now, I have to give you a massive warning here. Sometimes you need code from both versions, and those automated IDE buttons, they aren't always correct. One of our sources highlighted a brilliant edge case for this. Imagine your current branch modifies a log message on line 42, but the incoming main branch renamed a variable on that exact same line 42. If you just blindly click accept current in VS Code, yeah, you keep your log message, but you completely revert the new variable name, which is going to break the code. In scenarios like this, you actually have to get in there and manually mix the changes, keep their new variable name, but apply your new log message string to it, and then manually delete the markers. So please do not rely blindly on those automated buttons.
Okay, so once your file looks exactly how it should, without any of those angle brackets or equal signs left over, you have to actually tell Git you're done, because Git doesn't automatically know you fixed it. First, run git status. This verifies which files are still marked as unmerged. Then, once you've edited and saved the files, run git add with the file name. This step is absolutely crucial. Staging the file is how you explicitly tell Git, hey, I have consciously resolved this conflict and this is the final desired state. Finally, you just run git commit with a descriptive message to lock in the merge. Bam, your conflict is officially resolved.
Section 3. The secret escape hatch.
Look, sometimes things go wrong. If you find yourself in an absolute panic, do not worry. Simply type git merge-abort. This is your ultimate safety net. If you mess up the manual resolution or you're just feeling completely overwhelmed by a massive file, running this one single command cancels the merge entirely. It takes your working directory and completely rewinds it back to the exact state it was in right before you typed git merge. It is a total undo button. You can step away, grab a coffee, go talk to the teammate who wrote the incoming code, and just try again later when you're ready. Oh, before we wrap up, it's really worth noting that there is actually a second type of conflict you might run into, the pre-merge conflict. Sometimes Git straight up refuses to even start the three-way merge algorithm. You'll get an error saying your local changes will be overwritten. This happens when you have uncommitted, unsaved work in your directory that overlaps with the incoming files. Git is actually doing you a favor here. It's protecting your unsaved work. To fix this, just run git stash. This temporarily sets your local, uncommitted changes safely aside, basically clearing the board to a clean slate. Then you can run the merge, resolve any normal conflicts, and just pop your stash back later. Easy. So after all of that, we have to ask, are merge conflicts really failures? Or are they just Git asking you for a conscious decision? Really, it's Git acknowledging its own limitations as an automated algorithm and handing the steering wheel over to human intelligence. The next time you see those angle brackets, don't panic. Just remember, it's a multiple choice question. But you know, it does make you wonder, as AI coding assistants get smarter and smarter, how long will it be until they start answering these multiple choice questions for us entirely? Thanks for joining me on this explainer, and happy coding!